All right, let's kick it off again. Hi, Irina. Hi, everybody, and thank you for joining us today at Road to Nodes, the second workshop of the series. I'm super excited that today we're gonna have another Neo4j fundamental session about all the basics. What's a graph database? What's data modeling? How does Cypher work? And all the basic knowledge you need. But Road to Nodes continues, which was just kicked off basically last week. Across October for another 5 more workshops. So if you have registered for just the one today, you can always check back to the Road to Nodes landing page and register for the other workshops. We have something for lots of AI focus content coming up to you. So I'm hoping you are interested in those topics as well. But we'll cover the basics today, and later on we cover more advanced stuff from MCP, Neo4j servers to agentic AI and everything in between. So should be very exciting. I see people from all over already joining, so I'm really excited to see you all. So if you are joining live, then I like to see where people are coming from. We like to see that, so it's really great to see. I have people from Mexico, from Belgium, from Dubai, Germany, France, Canada, California, US. So it's really great to have you all, and really like to welcome you all to this Neo4j Fundamentals workshop today. Before we kick it off, with Irina, I'd like to make a few points about how this works today, because we tried, or we're working with this different platforms. So if you are not familiar with it, I'd like to give you a quick tour and a couple of basic points. First and foremost is we're going to record this session, so you will be able to get the video afterwards if something was too quick, if something you want to watch again, if something is something you want to look into later on, you can. If you have to jump off early because something else is important, then obviously don't worry about it. You'll get the recording of the full session today in your inbox in the next few days. We have a Q&A panel next to the chat window. So if you click on Q&A, you have the opportunity to ask questions. Please use the Q&A section to ask questions. If you do that in the regular chat, I might miss your question, and then we won't be able to answer it at all. Even adding it to the Q&A might not guarantee your questions will be answered, but because there might be lots. But we'll try throughout the course of this workshop. Irina and I will try to take a couple of breaks, and then when there's a good time for a break, we'll answer a couple of questions. I can also answer some of them in text. So if you see something that you want to clarify again, if something needs a little bit more deep dive, or if you have just generic question on all things graph, please use the Q&A function and send in your questions. If you just like something, if you think something is interesting or cool, or if you just want to share a general idea, go ahead and use the chat. But for questions, it would be nice to use the Q&A button. And yeah, I think with that, we are ready. I'm super excited. I'll be switching back to the back channel here, but I'll be here throughout the session, and I'll be in chat as well. So yeah, have fun, everybody. Enjoy, and I'll see you in a bit. And yeah, Irina, the stage is yours.
Thank you, Alex. It's really great to be part again of the workshop for the Neo4j Fundamentals. And thank you very much, everyone, for joining. I'll be keeping an eye on the chat and the questions as well as much as possible. But if you, for some reason, don't get your question answered in time, please write us an email or write to us on the community page, and we will be able to get back to you as soon as we can. So I'm just wondering how many of you are actually familiar with Neo4j and have heard about it before joining this workshop. Please let us know on the chat, and I'll also be looking forward to hearing more about your stories in working with Neo4j. So I will start sharing my screen. Okay, please let me know if you can see my screen properly. can see we have some answers about being familiar with Neo4j, so that would be great. You can ask more questions. You can also share your favorite fun fact about Neo4j that you have happened to find before this workshop. So all good? Everyone is able to see my screen? I'll take it as a yes, if so. Yeah, okay, thank you.
Yeah, all good, Irina. Yeah.
All right, so let's get started. This is the second series of the Road to Nodes, and perhaps you are already familiar. Road to Nodes is a series of events before the Nodes event, the main event that will happen in November. So I'll share more details at the end of this session. So please bear with me. My name is Irina Login. I am a technical curriculum developer at Neo4j. You can find my LinkedIn profile if you'd like to stay connected. So please feel free to send me a connection request, and I will happily share more Graph Academy links as well as we go along. So I've mentioned Graph Academy. This is our free learning platform, and if you have joined earlier, you must have seen a short video presenting the website that we have. And once you land on this page, you'll be able to see actually our fundamentals courses. But we also have advanced and topic-related courses depending on your preference. You can visit the website using the QR code that we have, or graphacademy.neo4j.com. Both of these would be taking you to the same place. Okay, so in this workshop, we will go through the basics or the fundamentals of the Neo4j terminology. So we will take it step by step. I will explain what is a Cypher query and how can you get started using Neo4j. So what do you need to be successful in this workshop is creating a free account on graphacademy.neo4j.com. You wouldn't need to put any payment references. You only need a valid email address to confirm your account, and that's going to be everything. And if you'd like to access the slides, this is the link for the slides as well. So I'll give everyone a few seconds to make a note of it. And you'll be able to access the slides, as I said, after this session as well, if you'd like to practice some of our hands-on exercises after we are finished with this session. Okay. I'll wait for a thumbs up once everyone has made a note and we're ready to start. All good? Awesome, thank you. Okay, so once you have started your Neo4j journey, you will obviously need to learn and become more familiar with the topics that you hear all the time on the market nowadays. So if you want to, for example, get started with graph data science fundamentals or building applications with various programming languages, building LLM or knowledge graphs as well, you'll be able to find these all for free on our website, and also get certified if you'd like to take on an additional challenge. And I'm looking forward to hearing more people getting certified, because this is a great achievement and statement of your understanding of Neo4j. Okay. We'll take you more to these slides and these details after we're done with the session. But just in a quick summary, we have a huge conference. It's called Nodes 2025, and also Alex will be able to tell you more at the end of this session. So let's get started. Okay, I am already logged into our Graph Academy website, and I went to the Graph Databases workshop that you will be also able to access from your machine, so you can practice at the same time as we go along and ask me questions or follow up on our community website. So as a summary, we have two modules: the introduction to graph databases where we will learn about what is Neo4j, thinking in graphs, how do you read a graph, how do you find patterns in the graph that you have just created, and more about creating graphs, more information. How do you get access to Neo4j? And the second module is going to be more about the Cypher query language. So I will introduce you to that, don't worry. We'll discuss about matching data. So how do you match certain patterns? How do you find certain information in your graph database? How do you filter the results that you have found? How do you apply orders and limits to the results? How do you aggregate data or collate data? How do you perform pipelining using the with keyword? So I will take you through what is the with keyword and why it is so important to us. How do you find the shortest path between two nodes or two items of information that you have in your graph? And in the end, I will take you quickly through how do you set up your Neo4j to get started. So this is going to be what we will cover today. And if you are curious to learn more, as I said, we have quite a nice portfolio of courses on our website. So for you, you'll see enroll into course, but I clicked on continue course because I have just started as a fresh student. So this is the first module, Introduction to Graph Databases. Okay, so let's get started. Okay, I will enter presenter mode. I hope it's quite visible on the screen. So what is Neo4j? Neo4j is a graph database. So that means the information is going to be stored in nodes and relationships. So that would be the representation of a graph. So a graph is a visual representation of data. And as you can see on this diagram that we have on the right-hand side, we have the small dots, and we call them nodes in our graph database, and we have lines that connect these dots eventually. So these lines are going to be called relationships, and we will learn how to create that from scratch. So the graph databases are extremely interesting and useful, especially when we want to establish connections between our data items. So as I said, the objects are referred to as nodes. So you can store objects, you can store certain events that you would like to process, and many other types of information that I will take you through step by step. So in this case, today we will discuss about labeled property graphs, and we will learn what is a label, what is a relationship, and how do we create those, and why do we need them. Okay. I hope we don't have any questions so far. All good? Okay. So the main 4 keywords that we use in Neo4j are nodes, relationship, labels, and properties. And you will see these 4 words everywhere you are going to find Neo4j. And that is because we store information or data items as nodes, relationships, labels, and properties. So let's take each one of them and understand what it means. So nodes are circles or dots in a graph. You've seen some really small dots on the previous diagrams. We can zoom in and we can see them as circles as well. So in this example, we have a social network. So we are describing here the social network or the community of Neo4j, where we have, for example, a person called Michael. We have an institution called Neo4j, and we have here a country called Sweden. So each of these entities right now, you don't see any line in between them. It means there is no connection established at this point. And let's see what happens next. Next, we see here another person that has come up, Sarah as well, and we have these small labels here, and we have person, company, and location. So we have we have the same label for Michael and Sarah because they are both persons. We have one single label for Neo4j because it is a company, and location. So if we had, for example, Germany, that would have been another node with the same label location. Okay, so labels allow you to distinguish between different types of nodes and filter the graph. So you need this information because you might have multiple persons in your graph, or multiple companies, or multiple locations. So this way you would be able to actually identify and later on establish advanced filters for your data. So nodes can have multiple labels here. You can create as many as you want. And for example, person and employee are two examples of how you can create labels. Okay. Now, a relationship is where we start to establish the connection between these nodes. So as we can see on this diagram, we have our node here, Michael, who is a person, works at Neo4j. So we have established a relationship already, and that means we have connected these two dots or two data items. Okay, so we have Michael works at Neo4j, and another relationship. Neo4j was founded in Sweden. So that means that we have created already two connections in our graph between the nodes. You also can notice the pointy arrow here that is going to establish the direction between nodes. So in this case, we go from left to right. We have a start node, Michael, and the end node is Neo4j between this relationship. Okay, so we have also let's say bidirectional relationship. So we can have Michael loves Sarah, but also Sarah can love Michael. So this is a small joke that we like to make that will help you remember that sometimes love is not mutual. So that means that also connections between data items doesn't always need to be bidirectional, but it can happen. Okay, so we have discussed about nodes, we have discussed about labels. Now we're discussing about, also we have discussed about relationships, and the last information is the properties. I've just seen the slides are too small, so I'm so sorry about that. If you are not able to see the slides correctly, please head to our Graph Academy workshop link that Alex can also drop on the chat, and you'll be able to find the slides and follow them as you would need. You can take them on another screen and so on and so forth. I hope this helps. So the link for this is pinned on the channel. Okay, I hope that's all right. Yeah, there's also a magnifying glass to zoom in, so I hope that works for everyone. Okay, so speaking about properties, these are key value pairs that are going to help us to describe more in detail the information that we're trying to store in a graph. So for example, we have here first name is Michael and last name is Faraday. We also have a date of birth that we have stored in this case. So nodes and relationships can have any number of properties, and those of the same type don't necessarily need to have the same properties. So in this case, we have here 3 key value pairs, and for Sweden we have only 2 key value pairs. So here we have the name, the capital, and these are not going to be the same with properties of the node called Michael. Okay, I have zoomed in to try and help around, but I'll need to exit this this slide right now. Okay, so this is the end of our lesson. Let's hope. Do we have any questions, or can we carry on?
We have one question that I think we could answer before we dive into it a little bit more, and that comes from Amit. Amit asks what a native graph database is, and if we could explain what we mean by that.
By native graph database, it means we are actually storing the database that we have we have just created. So it's solely based on graphs and not something else. Okay, I can see also explain labels again. So labels can be a dynamic piece of information that you will write as a description for that specific node or a collection of nodes. I hope that makes sense. Yeah.
Yeah, I mean, Linda has another question here. Struggling in understanding what should be a node in a property. If a company has 5 million customers, would I make each customer a node? And that's the question that comes up oftentimes, and that's really the challenge here is really, what do you want in terms of what kind of queries are you going to write? What is the use case you are working with, and is that that depends a lot on how you model your graph. What should become a property? What is becoming a node? What is a relationship? But if you can identify, and I think Irina will go into these a little bit. We have a smaller data modeling part of this segment. There's a whole data modeling workshop in Graph Academy, so you can really find out what is what. So stay tuned. I think we'll go into that a little bit, and it's still going to be a depends answer, unfortunately, where it depends on the responses and the queries and the answers you are expecting from your database. But yeah, let's continue.
Thank you very much, Alex. That's a great answer. And at the same time, if you're questioning whether you should create all these nodes or, or should you go more high level, is you have to answer the question, what type of data is connected? So identifying the data types that are connected is going to help you answer this question, depending on the use case. So sometimes you might have an employee node, or you might have all employees as nodes, depending on the use case. Okay. Do we have any other questions, or can we carry on? Could you relate these concepts with relational databases for better understanding? I will try as much as possible. But the scope and the time for our workshop right now wouldn't allow me to go very much in depth. However, I'm happy to answer additional questions if you write us an email.
Yeah, and I'll share the link. We have an RDBMS2 graph tutorial on the documentation. I'll post a link in chat in a bit, which is helpful. But yeah, I think we can continue, Irina.
Great, thank you. Okay, so this question is going to help also the mention about the relational database reference. So relationships in a graph are treated as with the same importance that nodes that connect them. So what we do is we don't store the information in tables, we store the information in graphs. So we store the information in nodes, and the connection between these nodes are going to be the relationships. So what might happen is you might have experiences as poorly performing queries when you are traversing complex schema of foreign keys and many-to-many relationships, where these things don't happen in graph databases because you don't have many-to-many relationships. You only have one-to-one, so you'll be able to set up direct relationships between the nodes, even though initially you haven't seen that as needed beforehand, or it just wasn't the case. And also we don't have the concept of foreign keys in the Neo4j databases. And if you follow the importing and modeling data, you will be able to actually get more in depth with the concept of how do you set up keys and indexes in Neo4j. So also another problem is dealing with the hierarchical data or trees, where the answer might lie at an unknown or varying depth. So you don't know where the answer is in your database, and you have many tables that you have to iterate and go through, and that might become a lengthy process. Whereas with Neo4j, you might find it faster to go through this type of process. So finding a path through an ever-changing data set with complex requirements, and for example, if you have a data feed that is always adding to your database and your database is scaling exponentially, and also the data set is obviously going to change as well, you might find it difficult and complex to actually match and establish the data connections. Okay, and then we also find it difficult to express what we're looking for. So sometimes writing the correct SQL query might take the longest time rather than finding the result. And we're treating this problem using Cypher query language, which is a more intuitive and human-like readable language as well. Okay, so once again, we need to understand the connection between the data that is established through relationships, and we don't use rows or tables. So this is the main principle that we go through in the graph database. Okay, so in a graph database, we are discussing about solving the ON problem. So the ON problem is actually creating complexity while going through multiple tables. So tabular data is going to actually create a ON complexity in terms of traversing all these tables, whereas with graph databases, we establish the connection between the information, and we do not need to worry about this complexity when querying the data that we have. So you can see here in this animation that how quickly the tables can grow when you are having, for example, live feed coming into your databases. Okay, so over the years we have many types of NoSQL databases that have come on the market, and they're all trying to solve the same problems that we have just noticed. And we have some different scenarios here that we'd like to mention. For example, a document store offers flexibility. We have a wide column store that offers scalability for large data sets. We have a key value store that provides simplicity and high performance, and graph databases that enable efficient modeling and querying of complex relationships. So these are all features and advantages of NoSQL databases, and we are establishing that graph databases are also part of this category of NoSQL databases. So treating these complexity problems is a serious mission, and there are different types of databases that have tried to solve this problem until now. Let's see how graph databases do this. So when we create a relationship between two nodes, we are actually storing a pointer or a reference to the relationship with each node. So that reference is going to be stored, and then when we try to retrieve the information, we'll actually access the reference behind the pointer. So that means that the query time will remain constant to the size of the relationship expanded. So regardless of the overall size of the graph data that we have, because we have just established the connection between these two items of data. Okay, so I hope we are all good to go now. Do we have any questions? Nothing yet? All good? Let's see.
So there's we could talk about this now, I think, but I think let's do it now. Maybe Marina asks, can you import nodes and labels from other databases? So I think it's a little bit, now we're covering a little bit more of the basis, but I think it's interesting to discuss this a little bit, at least not full-fledged on how importing works for sure, but what's the deal if you're currently having a database, a system of records? How do you get your data into Neo4j?
Yeah, that's a nice question, and we also take a good pride in being able to import data extremely fast. So the practice would be you would need to create a CSV schema of your data and then import a CSV schema or load it into the Neo4j graph database. For advanced developers, we also do connectors, so you can just set up connectors between Neo4j and other systems, and you would be able to get the information much faster.
Yeah.
But yeah, this is a good question. And yeah, please go ahead.
There's also a Graph Academy course, which I'll share the link in chat on importing fundamentals, which you can do as a follow-up to this session today.
Yeah, thank you. We can see also the use cases. So we have this information in our documentation as well for our use cases. So in general, we have mainly 7 categories that we discuss about, but it can grow beyond these 7 categories. So we have use cases like cybersecurity, supply chain, financial recommendations, and so on and so forth. So the use cases can go beyond these categories depending on, is the information connected? If yes, then it's a use case, because this is the main principle of graph databases.
Yeah. It's generally, if you have lots of if you're writing lots of joins, for example, in a relational database, or if you have highly connected data, you want to query data from, you want to connect various parts in your existing data storage across silos, maybe, or across different storage solutions, and you want to get that all together, and you want to find out information that is not just within one block, but it's beyond. It's highly connected, and it hints at a graph use case. But yeah, like Arina says, we have. You can look at customer use cases that are available. You can get inspiration from there. You can look around on our website for those. And just to restate this again, we try to look at the chat, and I think we find questions that you post in chat. But if you can use the Q&A function, then it makes it a little bit easier for us to see what questions coming in.
Yeah,
right.
I can see. Yeah, I can see a healthcare use case, and we are also tackling this topic as well. Perhaps we can follow up on this. Yeah. But yeah, healthcare is also a broad topic that we discuss about in Neo4j, and I think we had also some live streams that would be good to rewatch or going through the docs as well. Yeah. Okay. Can we carry on, or do we have one more question? Yeah. So to me, it sounds like.
Yeah, let's carry on for now, and we'll do another break in a little bit.
Yeah. Okay, so how do we read a graph? We read the graph by using the Cypher query language. So although it might sound like it would be something complicated that you will need to spend many hours to study, it is not actually that complicated because it's using a native human-like language. So you can see here a match word that I will take you through. We can see the where word. We can see here a name mentioning and a return word as well. So it would be for someone who hasn't written any query language, would be matching certain details where there are some certain criteria, and then we will return a result. This is basically how you would read the graph. And you would also be able to find this query runner in your own browser as well. So if you'd like to run queries, we also have this capability for everyone to be able to run the queries as we go along. Let's see if I can maximize this. Okay, that's good enough. Right. So after you run the query, you will see here the result in a visual format. and you will see what exactly has been run. So if you run multiple queries, this is going to show you the history of these queries, and also you can export what you've just run, either the result as either as a PNG or an SFG format. You can favorite your queries, you can pin them as well, and there are many other capabilities as well. On the left hand side, you can see the result as a graph. Well, in our case, it's just a node, so it doesn't actually bring too many nodes or such a big graph. We can see everything as a table as well. We have a text representation, and you can also see the code that has just been run. So these are multiple types of visualizing the result of the query that has just been run. In case you're wondering what are you doing and how do you run queries. So you need to write the query on the top and then run it, or also you can just run the one that has just been saved, and you will see the result. You'll get an overview of the display as well. So we are going to play with the movie database, and this is a public database that we're using in our courses. The reason we're using it is because it is something very relatable to everyone, so you would be able to grasp the concepts without having to study too much about databases. So we will analyze movies, actors, and directors of our movie database and explore the movie ratings by users of the website. So I hope everyone has a favorite movie so far, and you'll be able to even add more favorite movies to this database during this session. So I hope this is going to be fun for you, and let's go to getting started. So we have person and movie nodes, and this is going to be the data model of your graph database. This is also the introduction that you will see in data modeling, and you will be able to go more in depth once you have understood how it works. So each graph in our database contains a person and a movie. Okay, so each of the person node might have one or more outgoing, acted in, and directed relationships. So that is because we might have a person has acted in multiple movies, and also we have a person that has directed multiple movies as well. Okay. So I'm just going to get back into the slides. Now, when we read graphs, we actually read patterns. So a pattern would be what we would achieve when we create a connection between multiple pieces of information or data. So when we create Cypher, we actually use a declarative query language. So this is going to allow you to find the patterns in your graph, and behind this is going to be an ASCII art style syntax, and you can also go and check out the documentation for Cypher and for ASCII as well. So for example, in this example, we have a person that is going to be in an acted in relationship with a movie. Okay, so on the left hand side, we're trying to find the pattern that was established between a person and a movie. So on the left hand side, we have a node. On the right hand side, we also have a node, and we can see with square brackets we have the acted in relationship, and also we have the pointy arrow here that is going to establish that the person has acted in a movie. We cannot turn the relationship the other direction. Okay, so if you can notice here, we have round parentheses for person and for movie, and that means that these are nodes. And it's very easy. Once you have run your first query, you'll be able to also identify and explore and be more creative with these queries as well. The next part is the name person here and the movie. So these are going to be the labels that we have for the nodes. So column label is the syntax for the query language that we use. And the pattern that we're looking for contains two nodes. So one node has the label person and the other node has the label movie. And this is how we try to find patterns on a certain criteria. The next part that is actually in the middle is a relationship, and I have just mentioned the pointy arrow, so we can also specify the direction, or we can use just two dashes, and that means we don't specify which way the direction goes because it can be both ways. Okay, so in this case, we will use capital letters for the relationships and we will use square brackets as well. And this way you'll be able to differentiate between the relationships and the nodes in your Cypher syntax. So as a recap here, we have nodes, we have a person label, we have a movie label, and we're trying to find the pattern between person and movie with the relationship acted in. So this is going to retrieve actually the persons that have acted in a certain movie. What we haven't discussed so far is also the dimension of these variables. So we have here a variable P for person for iterating over the person nodes, R for iterating over the acted in relationships, and M for iterating over all the movie nodes. So we are going to use also variables if you are comfortable with any sort of programming languages. You might have used variables in general as well. So what we need in order to retrieve results is having to match a pattern. So we're going to match a pattern, and I've also mentioned the keyword here, and this is the match clause. So the match clause is going to be used to find the patterns in the data that you have just saved or defined. So after we have matched a certain pattern, we want to establish a filter. So in our example here, and I'll try to maximize as much as possible, we have a where clause where the person's name is Tom Hanks. So we're going to try and find in which movies has Tom Hanks played. And in the end, we will return also the person, we will return the relationship type, and we'll return the movie as well. So if we go ahead and run this, we will find that Tom Hanks has played in all these movies, and this is a very nice and visual representation of the graph that we have just discussed about. So if you want to explore all the other nodes, you also have these functionalities, and you will get more details. So you will see more other properties here. So for example, you will see the plot, you'll see a poster as well that you'll be able to access a release date, and so on and so forth. So you can be as curious as possible and explore the movie graph database that we have. Okay, so when we create or when we start to go for finding a certain pattern, we can keep it simple, but also the complexity can increment as much as we want to go more in detail. So we will also run this example. And here we have an acted in relationship, and we're trying to find the movies that Tom Hanks has acted in. And then in the second one, we will have all the actors in the movies where Tom Hanks has played in as well. So you can see here in this table, we have quite a lot of results. So we have 114 records in the database. If you scroll down to the end, you'll be able to find all the details about these results. So you'll have actor, movie, and role. And here you will see that we have returned the name of the actor as being the header of this representation. You can return the title as movie. So you have here the movie that has just been returned, and the role is going to be displayed here. So this is the role that each of these actors has played in the certain movie. Okay, any questions so far?
Yeah, we have a couple of questions. A few people seem to have connection errors. That's it's unfortunate. I posted in chat, so sometimes it helps if you refresh your page to get the connection back on. If you are behind a company firewall, that can also be the reason why you might not be able to get the connection, because then it's blocked, and then you might want to use a different network. If that is not possible, you can, maybe it's too short notice for this one, but as I said, the video is recorded. You can always download Neo4j locally on your laptop, and then you don't have to connect through the internet through it, and then you do it locally in parallel to the workshop. But that's probably not a little bit too much prep work now for getting it done.
Yeah. So is this error after you have created an account and logged in as well, or before that?
I think afterwards, when people want to execute queries and in the database, where there's a bold connection error, I see, and somebody says, "Oh, connection timeout." Yeah.
Yeah. Okay. I'm so sorry to hear about this.
Yeah. Sorry. Then there's a question from Adita. Well, actually, let's table that. We'll come to that a little bit later. I'd like to answer Amit's question first. Amit asks, when any node or relationship is created, what properties are created by default by Neo4j? And then because he sees an ID created for a node, maybe we talk a little bit about the schema free-lessness of Neo4j, and that there is lots of as much freedom as you like and as much restriction as you like when you're working with graph databases.
Yes, exactly. So what you see is going to be just the number that was associated with the reference, so the pointer that we were just mentioning about, and then you will be able to create the relationships and the properties that you need. By default, you will not have any property or relationship or label in the graph if you have not decided to create that.
Exactly, and then that gives you the power to decide, okay, what values do you want, what properties do you want? Again, to the question earlier, what is a node, what is a property, what is a relationship? You have the complete freedom, but you can use indexes to find things, and you can use constraints to make sure that certain sets of values are there when you enter new data to your database. So technically you have the complete freedom of doing whatever you like, but usually it makes sense to set up a couple of constraints, and depending on what your application is currently aimed for. And I think that goes to the next question that comes in from Radhika. Radhika asks, can a node have multiple labels? For example, a person node can have the label as actor and director and so on.
Yes,
that's
this
exactly
is
what it is.
Yeah, we can have multiple labels for nodes, and they don't need to be common between nodes as well.
Yeah.
So that's the flexibility of and one of the advantages of using a graph database, because you can just describe the information as it is in reality without having to force another data item to match what you've just created before.
Yeah. And then one more question from Andre. Andre asks, can you query for relationships or only for nodes?
You will query for patterns between the relationships and the nodes. So if there's no pattern, it will be no result returned, and you also will have the freedom to create that. So you can return only nodes, or you can return only relationships if you want. You can return any piece of information that you need. You don't have to set up a certain boundary.
Exactly. Yeah. That is. Well, there's one more from Madeleine. Maybe let's do that as well. Does GQL have the ability to run calculations over walks in the graph, as in if the relationships represent logical connectors? It's a little bit more advanced, I guess, but yeah. So we we have the ability to calculate. So I think I'll share the link with the documentation to Cypher with you.
Yes.
There's lots of operators, lots of we show in here the basic things you do to query and to retrieve information from a graph, but you can definitely do more advanced things within Cypher to get exactly what you describe, operations and calculations across your graph database.
Yes, so I was trying to think of a certain use case that they would probably want to share with us, so we can give a more detailed answer.
Oh yeah, yeah, and aggregations exactly like Shachai Chase writes in chat. You can totally do aggregation as well. Yeah, absolutely.
Yes,
All these
so
things
this
are possible.
aggregation topic, yeah, is going to be covered today a little bit, and also we are covering it more in depth during our Cypher courses that you can also access for free. And I think we have also previously recorded the Cypher lessons as well on YouTube.
There should be some, but yeah, we'll do them regularly. But I don't remember exactly when we did the last one. But yes, you can find on our YouTube channel the relevant workshops on the topic. Yeah.
Yeah. Okay.
Okay.
Are we ready?
Yeah. No, let's continue. Yes.
Okay. Thank you everyone for the questions. So I will go through. Let me close this. Okay, so we've learned how to read a graph. We'll also learn how to create a graph, because sometimes we might look at a graph, we will see how it was created, but we would want to start something else as well on the side. So we can create a graph using the merge clause, and this is our recommendation as a good practice for you to start creating your graph. So the merge clause is going to create a pattern in the database, and will create this pattern only if it doesn't already exist. So you might already be aware of duplicates in your data and trying to clean that data after it has become worth of thousands of records is not let's say the most good experience for you to do. So this will also prevent this from happening by using the merge clause. So in this example, we are creating a movie node, and we're using the merge clause to create a movie called Arthur the King. So we are specifying here, create this node. So let me maximize it because it might be too small to read. So we are using the merge clause, yeah, and we are setting up where we're creating a node, and this node has the label movie that we have previously defined, and this movie has the title Arthur the King. So this is going to be the value that we will store. We will also set another property called year. So the year of the movie when it was released in 2024. And we will return the variable m. So we will return the node itself, and we can see here that we have just one node displayed as a representation on the graph, and on the right hand side we see the node properties. It has by default associated an ID because you will need a reference number, right? You will need also the title, so we have the title property here that we have just expressed through our sentence, through our clause. And we also have the year property, so you can see all the advanced details here. And this is how you can create a node. It is let me close this. Yes, it is a movie, and we have created a movie with a property embedded inside the merge clause. Let me go back. I am being I'm being kicked out of slide mode. Let me give it a second. Okay, so I'll just carry on like this and I will zoom in maybe a little bit. Okay. So the next part is how do you create a relationship? We have seen how do you create a node using the merge clause, and we can also create a relationship using the same merge clause. So here you will see that we are creating and matching, the patterns later on. So we are creating here a movie called Arthur the King. We are also creating a node for a user, and this is a new node. I have not introduced any user node at the beginning of the session, so it means this is a new node for this database. And we also have a property for this node, and the property is name equals Adam, as we would want to read it in normal human language. So here we would also create the relationship. So here is the part where we will say merge the u variable, which is going to represent all the users with the name Adam. And here is where we describe the relationship. So we will have the rated relationship, and the rating property of the relationship is going to be 5, because we would say Adam has rated Arthur the King with a score of 5. So we will establish this relationship as having the user as a start node, and also the movie as the end node. So we will set up the direction between the user and the movie, and also mentioning that the rating is 5. So we have already set up a value for this. And in the end, we are just returning all these variables. So we will see how it actually looks like when we run it. Okay, so we can also edit the query here when you are trying to change the query. If you have made a mistake, you can also edit it here. And in the end, we have the Adam node and we have Arthur the King node. So let's say if I wanted to just delete this and return the U variable and R variable, let's see what's the result going to be looking like. So here we will have only the user node, and we won't be able to see any relationship because we can't just have drawn an arrow towards nothing if we don't want to display the other nodes. Okay, and then I clicked on the associated graph with this node, and I have also seen what was hidden, although initially I didn't want to display it for my query. Okay, so we can see the rated here, and we see that even the relationship has an ID as well as a reference number, and the rating is 5, which we have just expressed through our query. Okay, so this is just the screenshot of what we have obtained after we run this query. Okay, so now the fun part begins, where you will have to think of your favorite movie and add it to the database as well in your browser. If it doesn't work right now, you can also try it and refresh it in your own time. So what you'll have to do, you can also search for the most recent movies that already might be in the database. So you do this by matching a pattern. So you would match all the movies where the release is not null, so it means it already exists in the database, and we will return the title of the movie as a title representation on our result dashboard. We can also return the URL reference of the movie, and so on and so forth. And another bonus here is that we can order the results, and we will discuss about this as well with respect to our time today. And that means that we are ordering the result in a descendant limit, in the descendant manner, and we will limit the number of results to 5. So if we run this, we will see that we have 5 records that have been displayed, because this is what we have just created in our query. So if I limit this by 10, let's see if I actually have 10 results. Yes, we have 10 results that we have obtained by running this query. So if you don't necessarily feel that the result you have obtained is what you are looking for, you can also recreate the query and run it again, and you will be able to find new results. So you can see the previous query that was run and the current query that you can also edit in your editor. Okay, so you can also modify this query and create a new node adding your favorite movie and the user rating. Okay. So let's get a bit into how you can get Neo4j to run on your machine. So in case you would like to run these queries on your machine, Neo4j can be installed as a on-prem solution, but also as a fully cloud-hosted solution as well, and this is called AuraDB. So you have the installation link here, and you will be able to you have the console link, and you'll be able to navigate to Aura and create a free instance using your email account. So this is going to be a fully managed cloud database as a service that you can use for learning purposes, or later on for your company for production and more advanced purposes. Okay, so we have multiple tiers that you can use. We can use the community tier that you can also get started right now for free, and then later on you can establish a enterprise edition connection for your database. So the enterprise edition provides more corporate level features, for example, role-based access control and LDAP support. So if you have a team of various team members and roles, you can also describe in a granular way their role and access to the database and what they can and cannot do. So looking at AuraDB, this is a screenshot of how it looks like for the first time when you are just creating your free tier. So you can see here this database has been paused. It means the free tier trial has expired, and that means that you would only be able to use the free tier for a certain amount of time. And once you have completed the learning, I would recommend making a copy of your data and maybe having it later on as a reference. So if you'd like to use the desktop version, you can also do that regardless of your operating system. You can have a Linux, macOS, or Neo4j installation, or a Windows installation for Neo4j, and you'll be able to download this for free on your machine. And for cloud deployments and Docker, we also have a great documentation hub that we also have linked here. So I don't know if we already have it on the chat. I can add it at the end of the session if not. But yeah. So this is how you can get started. You can go through the documentation guides. You can also go through the Neo4j fundamentals and Cypher fundamentals guides. and you can get started with Neo4j.
Cool. Which link were you looking for to post in chat?
Let me go back. So the Neo4j cloud deployments documentation.
Yeah. Okay. I'll share that in a bit.
Okay. Thank you.
No worries.
And then the Docker documentation as well. Okay. Do we have any other questions on the chat? Let's see.
I had actually a couple marked, which I thought were interesting from the Q&A channel. I can read them. Here we go. Let's start with Marina's question. Marina asks, can you restrict access to certain nodes and relationships in the GraphDB to different users or roles in an institution, or generally, how do you deal with sensitive data that not everybody should have access to?
I would say separate the data into different instances.
You could do that, yeah, but and we also have pretty robust roles and access management system within Neo4j. So with that, you can keep your graph as a whole, and then even if you have certain information on, let's say, a certain relationship, which is maybe patient information or something, you can say this information is not for certain roles to be accessed, but the person who writes the query can still traverse the relationship, but does not see the information that's there. So you can pretty robustly store and manage your users' rights and access abilities there. So you have a good management system. Plus, then you can connect to existing role-based access management systems that there are in the organization already. So you can connect the flow here.
Exactly, and then you can also assign the viewer role if you'd like a person to only view the data as well, and not something more.
Yeah.
But yeah.
And then one question from Kuldeep. Kuldeep asks, does Neo4j support versioning for data consistency?
Versioning of the database instances that you have?
Yeah.
I guess that was the question. Yeah. In this case, I don't really recall from my memory being possible, but I would suggest taking snapshots. So that would be sufficient for managing your versions, and storing in your private GitHub the schema of your data.
Yeah.
Or storing it in a secure bucket.
Exactly. You can always make a certain history of your own by adding next or new relationships, or is current and then old going back in history. So it is a bit of it's not as ideal. We are in the scenario, but it is a workaround. I would say is doable to get that implemented.
Yeah.
And then there was one more question from Sean, I think, but maybe we scrolled by it a little bit fast. Sean asks, why was there I think you had a query open a little bit ago, but maybe we can still dissect it. Sean asks, why is there no arrow between user and then -2 and then in brackets R rated rating 5, but there was one between rating and movie. I think we just showed the relationship sometimes with an arrow, sometimes without an arrow, and why is that? What's the difference between having an arrow in relationships and sometimes you don't have an arrow there?
Yeah, that's a good question. So the arrows sometimes can raise some confusion, and I can also explain with the information with graphics that we have displayed here. So that is because the no error representation, it means it can be a bidirectional relationship. But if it's a certain direction, it means it can go only one way. So this also helps when you're trying to find the shortest path between two nodes. You would establish the directions. So if the direction is the opposite way, you cannot traverse the graph the direction, and you will have to move through other nodes to get to your end node that you're looking for. So this is the reason why sometimes we don't mention any direction, or we mention some certain directions that we only want the data to flow into.
Yeah.
Yeah.
Cool. There were a couple of others, but I think we can continue so that we don't lose too much time, and then we'll have another break for more questions. And then I think I didn't forget you, Adita. We'll get to your question later.
Awesome. Okay, so the slide mode, I hope it works well for everyone. I will close this for a second. See? So in general, I hope you have heard about knowledge graphs. If you haven't, this is the right place to learn about it. We also have more in-depth courses about how you can build your own knowledge graphs, and I would highly recommend this as general knowledge, if not for more advanced purposes. So generally, knowledge graphs provide a structured way to represent your data. So for example, if you want to build a knowledge base about something that you've learned, a knowledge graph would be the best use case for this scenario. So for example, here we have a blog post, a node that is also an article, and this blog post refers to database. And in general, this has a technology label, and also this blog post article is about Neo4j as a company. Also, this blog post is published on neo4j.com, but it could be published on other websites. So we can create more nodes and more relationships between the pattern that we have already on this graph. So the knowledge graphs can break down sources of information, as in categorize them, but also create a connection between the topic and integrate them into other topics as well. And that's why the knowledge graphs are so useful in building the generation engines and so on and so forth. So if you haven't checked already the knowledge graph term so far, it would be a great starting point for you. Okay, let's see. So we are going to go to matching data. So how do you match more patterns and the data in your graph? And we will discuss with, in general, an overview of the patterns here. So we have already introduced the patterns, and now we will go more in depth with the patterns, and we'll also have some exercises. So we're getting closer to the purpose of the workshop, which is having hands-on exercises for you to get started with. So in Neo4j, you can find the patterns by using the Cypher query language. And for example, in this case, we have a movie node, and this would represent also trying to find an action movie. So the whole pattern will take you through the movie node, will set up a in-genre relationship, or try to find the in-genre relationship if it is already existing in there, and also try to find the nodes that are carrying the property genre and they have the name action. So in general, we will try to find as many patterns as possible in a graph, and that means that we will also try to understand all the information represented in the graph. So you can use a match clause to find data in a graph, as we have already introduced this. And for example, in this case, we're trying to find all the action movies and return them in our representation. So let me maximize this and go into the Cypher query. So we are matching all the nodes that are labeled as movies we're going to go through, let me not modify this. We're going to go for the in-genre relationships and also find the genre nodes that are carrying the name action, and we'll return them. Okay, so we have here 1,545 records for this query, and this is not displayed on a full screen. This is displayed just like this, but you can also maximize it, and you can export the results as CSV or JSON that you can also use maybe in other places. Okay, so we have also introduced the where clause at the beginning of this session, and we're going to get a bit more in depth with it. However, I would recommend the Cypher course if you'd like to get more advanced in learning about Cypher. So you can filter the results of a query using the where clause, and this is going to bring you a filter. So filtering information in Neo4j and in Cypher is done using filters, and in our case here we have the where filter. So we can also change filters here. So we can use where the name of the person is Tom Hanks in the movies that he has acted in, and also the year of the movie that was released is 2013. So we are setting up additional advanced filtering for the results that we would like to obtain by running this query. So we can see that now the number of results has significantly reduced, and we only have 3 records displayed after running the query. It means that we can reduce the number of results and only bring the most relevant ones that we would actually need further on. Okay, so we can also order and limit our result. We have already introduced the order keyword and the limit as well. So we can also run this query and see what we obtain. And if you just copy and run the queries, you wouldn't need to do anything else. It will just run in the right-hand side browser. Or console, if you want to call it so. So here we are trying to find all the persons that were born in 1980, and we will return this as birth date in our representation, and we are also ordering the date. So here we can see that we have the oldest person, the oldest birth date to the most recent one. So we can establish more filters this way. So we can also split dates into components. We don't necessarily need to display all of them. We can separate the dates using the year, month, and day properties that are already represented in the database. And we can set up even more advanced ordering depending on the filter that we would like to have. So for example, here we are ordering the results in a descendant order for the born representation or for the born keyword, and we are displaying the name in an ascending order. So you can just run this as well, and you can see the results now applied against our filters. So you can also run these queries on your own and be creative as much as possible. You can limit results, so using the limit keyword, and you can add it at the end of your Cypher query after you have described the pattern that you would like to look for and the filters that you would need to apply. You want to limit the results because perhaps you only want the first 5 results that you can obtain. So if you run this query, you will also be able to see how this works, and you will have 5 examples of movies that were released in the year 2000, and you would have them also ordered. So on the left-hand side, you can see order by released. So you can see the released dates ordered as described. So now we have some hands-on exercises that you can also run on your browser. So you will have to complete the queries to find some data that is needed in our movie database. So for example, you will need to find the Steven Spielberg movies ordered by the year they were released in, and you will see a box that you can also use to fill in the information needed, and then at the end you will need to run. So if I just run it right now, I would get an error because this is a syntax error, right? This is a question mark, a symbol that is not recognized because I have not defined what does that mean. So I'll let you think for a second. What would you have to write here? What would you have to write in your filter? So the p variable, the p letter here is going to represent all the persons, right? So you have to think, what would be a Steven Spielberg representation for a property of the person in your graph? Also, you have advanced filtering, so you would need to think, what would you like to write here to display the released the release dates, and in the end you would need to return title and released. Okay, and challenge number 2, return the top 10 most recently released movies. And again, this is a bit more complicated, but shouldn't be a challenge right now because you already know how to create filters, right? You know how to return results. And here you might need to think, how would you display only 10 records? Okay, so this is going to be the challenge for you today. And in the end, if you get stuck, you can also click to reveal the answers, but I will not do that because this is the place where everyone has gathered to learn. Okay. Another important action that you can do using Cypher is aggregation. So aggregating data, it means using a return clause where we would want to collate that data and display it as a result. So for example, let me maximize here. Using the count function, we can return how many movies are displayed in our database. So if I run this query, I will find all the movies in the database, and in the end, I collate them all in a result. I count how many movies I have, and I display all the movies that are in the database. So in total, in the database that we're running today in Graph Academy, we have 9,126. So if you were to add more movie nodes, this would increment automatically as well. You can also return multiple types of information in a return clause. So that means that you have collated all the information that you needed through finding patterns, applying filters, ordering, and so on and so forth. And then you can also represent it as a result. So in this case, if we run this query, you will see that you have here the genre adventure has 1,117 movies and so on and so forth. So what it does, it is displaying all the genres in the database and is calculating how many movies are per genre. So for example, we have 4,365 drama movies and so on and so forth. So you can see how you can easily calculate and categorize the information that you have depending on what you would like to obtain as information. So as I said, you can also return and order the data that you have. So here we are ordering by the number of movies in a descending order. So we can see that the drama movies are on the top of our list with the highest number of movies of 4,365. And there are many other functions. For example, you can use the sum function to calculate a mathematical result. So this would return the total sum of the revenue that was calculated by that movie. So here is not going to display the currency, it's only going to calculate the mathematical result of a sum of multiple numbers. So you can also go more in depth. I will not ask you to write all of this right now because you might need more time to get used to this Cypher query language. But you can also, for example, find the most profitable actors by grouping movie revenue by actor. So you can think who was the most profitable actor in the movie, in a certain movie or in general. So you can even add more filters based on a year and make a nice leaderboard as well. And yeah, so this is an example of how you can actually categorize your data and aggregate it in a certain way depending on your criteria. You can use average, so you can calculate the average to find a certain value of a property. So, for example, the average rating of all movies in a data set. So we have here for the movies titles, the average rating for the Toy Story, for example, we have an average rating of 3.8. So let's say at home you have some old CDs on a bookshelf and you wouldn't want to throw them away, but at the same time you don't want to spend time every single day to search for every single movie, which one was the best. So you can build your own movie database and you can build this very easily and have it as a small app on your phone or a representation of the database itself as well. You can have it in Neo4j, and whenever you would want to decide which movie you'd like to watch next and you don't remember what was the average rating for each movie and if it's worth your time or not, you can easily decide on which movie to watch next by performing this query. So adding also orders and limits as well. There are more complex queries that you can run. And I will skip through the first two challenges for this lesson. And these are what movie has the most actors. And you would need to actually edit the boxes that you will have. So the text fields that you'll have on your screen as a student mode would be the place to go to. And in the end, you can also run the query or you can copy it and run it separately in another Neo4j instance. So take a few seconds to think about it. And also, what is the highest rated movie starring Tom Hanks? So as you can tell, the favorite actor of this workshop is Tom Hanks, and we want to know what is the highest rated movie. And I will not tell you the answer here, although if you get stuck, please remember you can reveal the answers as well. So take a few seconds to think about it and let us know if you get stuck or if you have any questions. Okay. One of the last clauses that we will discuss about today is the with keyword, and it is quite a simplistic clause that we will use, but we will also use this in a powerful way. So you can also find the power of a with clause when you want to chain parts of a query together. So when you have multiple queries and you don't want to create, 500 characters of a query on a single row, you would break it down into multiple smaller queries that later on you would chain using with. You can also control the query flow, and you can also aggregate data and pass it to the next part of the query, just so you can keep your scripts organized. And this is an example. You can chain queries using the with keyword. So for example, here we will find all users who rated Matrix, and then the other movies that they have rated. So we have here the query that we want, and then we will have a variable passed for you and another one M that they will store the users and also the movies. Then we will find another pattern. Yeah, so this is the other half of the sentence. And we will also establish a filter as well, where we would want to return the name, the title of other movies as well, and the rating. So I have just run this query. Okay, so we have found all the users who have rated Matrix, the movie, and then the other movies that they might have related. So we can see here also the rating that they have given, and we will be able to analyze further the movie database and actually build a more comprehensive understanding of what is that we are going to watch and taking this decision further on. So filtering after aggregation is possible, and that is also done through the with keyword. And we will filter the results. Let me just run this quickly, and I will explain to you what it does. So we have the pattern finding. So we are using the match clause, and here we have exactly after the with keyword. So we have used the u variable that we have stored through our pattern, and then we are counting the number of movies, and we are storing it as a movie count variable. So as a result, later on or in the future Cypher queries, we will be able to relate to movie count as something that is already understood by the Cypher compiler. So movie count, if it's greater than 5, then I will return it, including the name of the user. So if the user has rated a certain movie and it has rated more than 5 movies, we're going to display. So we're going to find out which users have rated more than 5 movies and how many movies have they actually rated. So you can see here someone has rated 204 movies, which is impressive. And if you go through the results, you can find even other interesting facts about the movies that are part of the database, which you can also access. Okay, so you can do even more advanced operations, and we have some challenges here. You can order and limit as well. So using the with keyword and being creative with your Cypher query, you can order and limit as well, just as we have previously seen. So you can use the order once you have described the variables that you would like to use further on. You can use order, you can limit. So there is basically a lot of power in creating these Cypher queries and chaining with with keyword, because this is going to keep your code very organized. So here we also have 2 challenges for you, and we would like to also propose them for you to get solved. So we are trying to find the lowest rated movie that has a revenue of more than 1 billion. So if you're curious to see which movie was the lowest rated and it wasn't quite a good investment, you can find that by filling in the gaps here. And challenge number 2, of the top 5 users who rated the most movies, who gave the lowest average rating. So who has rated the lowest, depending on the movie that they have watched, and you will also want to retrieve top 5 users. So remember, how do you order, how do you limit a movie, and how do you chain queries using the with keyword. So this is going to be the last 2 exercises, and these are also hands-on, and you can work through them individually as well, or you can, if you get stuck, you can also reveal the answers. Okay. Should we stop for a quick question break before we go to the last lesson?
Yeah, that sounds like a good idea. And now I'll take the time to finally get to that question from Adita. She asks, I have read that using graph databases can provide better grounding or results when it comes to GenAI applications. So is it a valid choice to use Neo4j by default as the main knowledge base database for data storage for our GenAI app? What's your take on that?
Sorry, I didn't get the question. Can you please say it again?
Oh, the question is basically, Adita asks if GenAI applications work well with graphs and if Neo4j is a great choice for driving a GenAI application.
Yes, I would say yes, because you can find connected information and you can establish a knowledge graph, for example, using the graph databases. And that would take you through building the knowledge base that you would need to further use in the generational AI that you are building.
Yeah, and I will share with you. I'll put this in chat because we have a great, definitely for developers, we have a great resource guide on the GraphRag world, like what you just said, Irina, with knowledge graphs, also with GraphRag, and connecting and grounding an LLM into relevant contextual information that is interesting to your users of your applications, whatever you're building. So I'll share that with you all in chat as well, because I think that's a great resource for you to dive into the topic a little bit more.
Exactly. So we have the GenAI path on Neo4j that you can use for free, and you can learn about how you actually can dive deeper into this topic at your own time.
That's a great great shout out to the GraphRag courses. There is a full track on the Graph Academy dedicated to exactly building and how to build knowledge graphs, how to build grounded LLMs, how to build applications with GenAI in mind. So check that out. I think that's really good. And then there are other courses outside of this as well. So if you Google for deep learning, for example, with Andrew Ng, you find lots of interesting sessions there as well that are based on how graph databases and Neo4j in particular can help you improve your AI applications.
Definitely.
Another question,
thank you, Alex.
Yeah, thank you, Irina. Another question is from Anis. Anis asks if we have something like text to Cypher, text to GQL that makes it easier to write your own queries, especially when you're a beginner. I guess it makes it very hard to. Well, we try to make it as easy as possible, obviously, with the Graph Academy, but it is something you need to learn. Is it is there ways that make it a little bit easier for you to write queries in Cypher?
Absolutely, yes. And we also have the courses about it. You can also check our docs. We have the text to Cypher features of Neo4j that you can easily use when you are just getting started with Cypher. And also when you are in Aura, you go to your query editor. You can also use the AI generator of Cypher as well. So you can easily get advantage of these features, even if you are just using the free tier.
Absolutely. Yeah. Cool. Yeah, I think in the interest of time, because we have about a little bit under 20 minutes left, let's continue, and we can take some more questions at the end.
Yeah, thank you. So this is our last lesson, and it is an example of what you can do in a practical application, and also combining theory of the graphs in Neo4j. So this example is describing finding the shortest path between two nodes in a graph. And you can apply this directly in building a navigation system. So you can find the shortest path between two nodes using the shortest of k clause. So this clause is going to actually describe and find the shortest path for you. So when you're trying to find the shortest way from node A to node B, you will be able to do that by using the shortest clause. So for example, this query finds the shortest connection path between Tom Hanks and Meg Ryan, regardless of the relationship types. So regardless of the relationship between the nodes, we will try to find the shortest connection path between them. So if we have found shortest one, indicates that we want to find the shortest path found. So we can also do multiple hops along the way. But in this case, one is for the shortest path that we can find. So let me run this query as well. So we have Tom Hanks and Meg Ryan with one stop, or one hop, if you want to call it this way. So here we have just one node that is in between them. And Tom has acted in this movie, and Meg Ryan has also acted in this movie. Okay, so this is how you can find the shortest path between nodes. And please follow the Cypher language course to go more in depth with the shortest path. And I would suggest it's quite a great application when you want to get started with finding routes between nodes. Okay, so just to wrap up our lesson and our session for today, you can create an Aura instance for free if you go to console.neo4j.com, and I'll just write it quickly on the chat. Neo4j.io, sorry, not .com. You can go and set up your Aura account for free and get started with Neo4j. Also, you can download the Neo4j for desktop, and at the same time, you can use the embedded sandbox that we provide for a free learning account. So you have all the tools needed to get started with Neo4j, as well as setting up your Graph Academy account that you will also be able to use for getting certified as well. So I will stop sharing my screen. If we have any questions, I will be more than happy to answer in the minutes left.
Super. Thank you very much, Irina. That was very interesting, very informative. I think great start to learning journey. I hope you all had some interesting points to discover today, and hope you continue your path in Neo4j now. The course, this was just basically a little teaser. As you've seen what Irina shared, the course goes on a little bit longer. The full educational part of the introductory course goes over a couple of lessons, so you can continue your journey right from there. So you keep on learning there. We will, as I said in the beginning, have a couple more interesting workshops coming up as Road to Nodes, which we will cover, particularly to Anita's point, maybe the question earlier, lots of AI specific topics. We do mastering GraphRag. We'll do that next Tuesday at a different time zone, specifically for Asian time zone, so European morning time. And then on the next week, on Thursday, 2nd of October as well, we do finding connections to transform your document collections into a graph visualization. So that is also going into that mix of hybrid retrieval, GraphRag plus data visualization with Neo4j. So that should be interesting. Perfect. Thank you very much, Irina. Notes, as you have registered for this workshop, you are most likely also registered for notes. If not, you can always change that. But that's happening in on the 6th of November. So it's not 2 months anymore. It is a month and a little bit more. So that's coming up, and that's going to be very, very interesting. Lots of great sessions, lots of great topics across the time zones, 24 hours, basically interesting content. And the agenda is now available on the website. So if you want to check out what lessons there are, or what events, what sessions the event will have in store for you, then you can look on the website as well and find out more there. In terms of questions, Sorry, Irina, you want to say?
No, please go ahead. I was also wondering about the questions.
Yeah, so we have a couple of questions that I'd like to see what there are and if I can read some. So we had a couple of questions on subgraphs. I don't know. I know these probably the majority of these questions go a little bit more in depth than what generally we covering in this fundamentals workshop. But now that we have covered it, I guess we can go a little bit deeper. What's to say about subgraphs with Neo4j? Is that something you can dive in a little bit, or should we refer to the manuals for this one?
Yeah, sure. I think going to the manual is always a good starting point. But yes, it is possible to have subgraphs in Neo4j, as you can couple a connection. You can also decouple the connection by removing the relationship. And I would strongly recommend also the Cypher course again, because that's where you would actually learn how to delete a relationship between two nodes, for example. So yes, that is definitely possible because graph databases offer you this capability of deciding what you would like to do with the data and how you would like to organize the graphs that you already have.
Yeah, cool. And then there's a question from Andre. Andre asks, does Cypher have any major feature differences to regular SQL queries besides different keywords? It felt very familiar so far.
It might feel familiar if you're already, using other query languages. You can, if you know one query language, it is easier to learn the other one. So if you are just getting started, it is relatable to the human language as well. So yeah, um, I would say just finding patterns in general is what Cypher is trying to achieve at best, and also applying all these sort of filters and advanced querying of the graph database.
Yeah, and then maybe to round this up with the query language bit, Cypher is more or less the standard data query language for graph databases, and there has been a standardization effort from the ISO board, which is called GQL, similar to what SQL does for relation databases. GQL is what it does for graph databases, and Cypher is very, very close to that official standard query language format. So if you now learn Cypher, and if you now work with Neo4j, you have basically learned the standard query language for all graph databases, and that is useful. So it's not just for Neo4j. You can technically apply to other graph databases that are out there as well. Should you do, like to do that?
Definitely. And once you have trained your brain to think in patterns, it's easily relatable to other type of data as well.
Yeah, I think that's the most important point. Is a good reminder. Even if SQL and graph seems similar, or you're seeing some of this, the clauses seem them like to be the same. The most important bit is if you work with graph, think in graph. If you just try to adopt what you used to do with relational databases and put that over the graph, I think your results will not be very good. You will have probably long query time. You will have not a great performance overall. You need to think a little bit how to optimize your graph, how to model your graph, but also how to write your queries in that way. So that's the steepest learning curve, I would say, is not about, okay, do you have to learn a new language? I think when you come from SQL, it's probably very similar and very easy to do, but you have to wrap your mind around, okay, I'm actually not in tables anymore. I'm in a graph world, and I need to create a graph.
Yeah, definitely. Okay,
cool.
Any questions?
Yeah, I think we can close this out with one more question, maybe here from Anis. Anis asks, is the recording of the session available? Yes. So I will be sending you the recording of the session later this week. You'll get it in your inbox, and you can watch it anytime as you like. And yeah, I think with that, we're at the end of this workshop today. Thank you all for sticking around. Thank you for your questions. Thank you for your participation. And last but definitely not least, Irina, thank you for the workshop lead today. Thank you for helping today and for being a trainer.
Thank you as well. It's always great to be part of these workshops and to listen to as many questions as possible. If anyone would have any more complex use cases or questions for us, please write us to our community inbox or write on our community blog as well, and we'll be able to get back to you as soon as possible. And I wish you all a great evening and a great learning journey using graph databases.
Perfect. Because I just saw it in chat flyby, somebody wanted to get the link for the previous workshop. I just chatted in chat. There is the Road to Nodes overview page, and from there you can go to the one that we did last week. You can check that out as well.
Yeah.
Yeah.
Definitely.
Cool.
Thank you for having me.
With that, thank you, everybody. Have a good rest of your day, rest of the evening, and see you soon, hopefully next Tuesday for Mastering GraphRec or at any other workshop in the next coming weeks. Until then, take care, everybody. Have a good rest of your day, and see you soon.
Thank you, everyone.
Bye-bye.
Have a nice evening.